In today's video, we will continue looking at methods of examining and summarizing, both numerically and graphically, numerical variables or data. This presentation will focus on the first of two key numerical summary values for a two-dimensional view of data, known as the weighted mean or average. The mean is also called a measure of center. A related value, called a measure of spread for two-dimensional data, is the standard deviation, which will be discussed in a subsequent presentation. So on the screen, you can see that I've copied and pasted the dot plot that we created in RGuru, which was a reproduction of figure 2.4 from our textbook. Now I want to point out a couple of features about the dot plot. First of all, notice that there are two directions that are represented by the dot plot. There's the horizontal direction, which is of course our interest rate axis. And then there's the vertical direction in which we see the stacking of the dots. That represents the frequency or the count of each interest rate value. So for example, at 5% I have a count of 3. That means there were approximately 3 data values that had a 5% interest rate. And then at 6% there were 3 such values. At 7% there were 5 such values, and so on. So again, we have a two-dimensional view of the data, horizontal and vertical. Now, what I also want you to do is think of these dots as each representing, say, a 1 pound weight. So at 5%, I have a weight of 3 pounds stacked there. At 6%, a weight of 3 pounds, and so forth. Where would I need to put this triangle, which is a pivot point, so that all of the dots on top of this particular axis would balance out with one another if we look at this horizontal axis as being like a seesaw or a teeter-totter? Now, obviously, the location I've put the triangle or pivot point is too far to the right at this point because there are way too many dots, far too much weight on the left to counterbalance the dots that are on the right. So I would need to move this pivot point, let's say somewhere right around here, like maybe at about 11% on the horizontal axis, on the interest rate axis. Now the weight on the left would be counterbalanced by the weights that are on the right if we look again at this as being like a teeter-totter or a seesaw. This is a very special value that this pivot point is located at. We call this the weighted mean or average value. And we can see now why it's called a weighted mean, because it's the place where all the weights on the left are counterbalanced by all these data values that are represented as dots and we're looking at as being weights on the right. Now, one other thing I should mention about the mean value is that it is what we call a measure of center when we are looking at a two-dimensional view of the data. Now, although we've talked conceptually about how to find a weighted mean or average for the interest rates of the Loan 50 data set, your textbook gives a formula for finding the weighted mean numerically, as well as two other quantities, the variance and standard deviation, which are all important quantities associated with a two-dimensional view of data. I want to go ahead and take a moment to show how to find those same quantities using RGuru. So I'm going to left-click on Data, left-click on this Functions button, and select Summary Statistic from the menu. I then come over here and I select Loan 50 as my data set. I left click in the search box for numerical, and I'm going to start typing in interest, which is the variable I'm interested in. And then over here on the right of this dialog box that we're in the middle of, I see that I can select a whole bunch of different statistics. Now I'm going to leave the count checked. I'm going to uncheck minimum, median, maximum, uncheck the 2 quartiles, leave the mean checked, leave the standard deviation checked, and check the variance checkbox. And then I'm going to select the preview button by left-clicking on that. Left-click on this plus box in order to see the statistics that we were interested in. 50, of course, is how many data values we have. The mean value matches what we saw conceptually. It's approximately 11%. Actually, it's 11 and 567 thousandths percent. And then the standard deviation is 5 and 521 ten-thousandths percent. The mean is what we call a measure of center. The standard deviation, which we will discuss a little bit later, is what we call a measure of spread when we're looking at two-dimensional views of data. And that completes our look at how to use our Guru to find these important two-dimensional statistics for the interest rate variable in the Loan 50 data set.